Okay, kids, so we're not going to cover everything on this sheet. Some of it we're not going to do at all. Some of it I'm just not going to cover in the video. You should really do on your own. I'm hoping that these terms that you see here in the top in the opener, that these all ring a bell. You should be familiar with this from previous, introductory experiences in geometry. What makes something a point, a line, a plane, array, all this good stuff. Please spend a little bit of time, not a lot, but spend a little. See iBook page, sorry, not page, but section 1.2. And just to kind of refresh your memory on these things. All right, gives you some definitions there. I think most of you just spend a few minutes and you realize that you're okay. Okay, this locus section we are not going to cover, so don't worry about that. We're not going to cover it all, so it's not like you have to do it on your own in the book or anything. So I'm just kind of using a sheet from before, but we do need to talk briefly about this union and intersection. I'm sure you've heard of this before. And union is represented by like this U shape for union, and intersection would be the upside down one. Remember, intersection is what something has in common. What two sets, where do they overlap? Like in a Venn diagram, like the middle area of a Venn diagram, that would be intersection. What do they share? What do they have in common? That's intersection. Union is what do two separate sets form together. So union typically is a bigger solution because it's what do you form together, okay? I'm going to do some of these together. I'm going to talk through them. Having different colored pencils here is helpful, but let me show you what I'm talking about. Like, look at this first one. Remember, this is segment. I apologize that these arrowheads are really small, but the arrowheads make a difference. Like, that's a segment. This is a ray. This is a line, okay? So here we're talking about the intersection of segment AB and segment BC. So where do those two things intersect? Clearly, they intersect. What do they have in common? Right there, they have point B. Okay, that's point B. That's the answer. Now, if this had been upside down, if this had been the union, we would have said angle ABC. Okay, so that's a difference, because union is what do the two things form together. Intersection is what do they have in common. All right. Next one, watch this. So that's ray EC. Remember, a ray starts at E and it goes forever through C. And it says union with ray EA. So that starts at E. Okay, now if this was intersection, it would just be point E. But this is union. What do these two rays form together? They form line AC. And make sure you put the right symbol up top. Now, we could have characterized this a bunch of different ways. We could call it line AC, line CA, line EA, AE, EC, CE. I think there's like 6 different ways you can do that. They all mean the same thing. All of them would have been okay. But you have to have this line notation on the top. If you had ray notation or segment notation, that would not be correct. All right. Next one, we have the intersection of two lines, AC and DB, and clearly the intersection of those is point E. So I'm hoping you're already getting the hang of this. This shouldn't be that hard, but it always causes more difficulty than I expect. Now this next one here, DC, it says segment DC intersecting with AB. So where do these two things cross? What do they have in common? If you're a little bit stumped, you're probably right, because they have nothing in common. Their intersection is just the empty set. They share nothing. All right. Now, AC, so ray AC, and then it says intersecting with EC. So that would be from here. So what do they have in common? Where do they overlap? And they overlap from E to C forever. So they have, it's ray EC. Look for the overlap when you're doing intersection. This next one is union, BA. And it says ray, so it goes forever. And BC says ray. Go. Now the union would be angle. That's the angle symbol. ABC. Okay. Now I could have called it angle CBA just as well, but the B has to be in the middle. Now remember, that's the union. It's kind of like the opposite of that first one that we did. You know, the intersection would have just been point B. And this last one, of course, that's just going to form a triangle if you do the highlighting. Triangle CEB. And how you name that doesn't matter. You could have, there's a bunch of ways to name that, right? CEB, BCE, it doesn't really matter. All right. So that's union and intersection stuff. Now, there's some problems on the back. I'm not going to go over these here. If you feel like you need to practice, you can go over these, and the answers are going to be on the solution document that will be posted on current unit on Canvas. Okay. What I do want to do is spend a little bit more time with these clock problems down here at the bottom. Find the measure of the angle formed by the hands of a clock at each time. Now, when you see a question like that, folks, that just always means to find the smallest angle. So you're always going the short way around between the hands of the clock. And you know, this first one's really easy. If it was exactly 3 o'clock, you know, we would have what? The big hand, the minute hand up on the 12, the hour hand there. There are 360 degrees in the face of a circle, and obviously that's a quarter, so that would be 90. That's a no-brainer, not hard at all. Now, they do get more interesting than that. I apologize that these circles are a little bit on the small side. So B, for example, you know, most of you can probably guess that one as well. Again, your clock doesn't have to be perfect, but you don't want it to be bad either. 4:30, let's think about that. So 4:30, the minute hand would be pointing straight down. There's the 4. The hour hand would be exactly in the middle between the 4 and the 5. Now remember, there are 12 sections of a clock. So 360 degrees divided by 12 would be 30. So each one of these full sections is 30 degrees. If that's 30 and this is exactly in the middle, this must be 15. So this angle is 45 degrees. Okay. Don't worry, we'll get to some harder ones in a little bit. I'm just kind of talking through these simple ones. So 7:20, that one's not that hard either, is it? Because 7:20 means the minute hand is right there, exactly on it. And 6/7, the hour hand is going to be roughly like that. Now, most of you can probably guess this one. See, we're looking at 1, 2, 3 full sections, so that's 90. And then you realize that, remember, this whole section's 30, but we don't have the whole thing. We only want this partial piece here, right? Now, remember, 7:20, we are 20 degrees past the hour, which means we're a third of the way. So if this is 30 degrees, this would be 10 degrees, right? So we got 30, 30, 30. We have 90. This is going to be 100. I'm not going to do D. That's going to be 142.5. What I do want to do is spend some time talking about E, okay? And I'll do that over here. It's important to draw a good clock. You don't want it to be really sloppy. So let's do the best we can. Now 11:04 means that my minute hand's going to be not quite on this tick mark here, right? It's going to be a little bit in front of it, and the hour hand's going to be a little bit past the 11. Now remember, the clocks the hands of a clock are always moving typically. So in the angle here, this thing here, we don't have a full section. We have two partial sections. Okay, we have this partial section, which has to deal with the hour hand. I'm going to call that section B. And then we have this section here that deals with the minute hand. Doesn't matter what you call them. This is just for our own benefit. I'm going to call that section A. So they're both partial sections. Okay, I'm going to do A first. A is pretty easy. Now remember, A is dealing with the minute hand. How many minutes does it take the minute hand to traverse from this tick mark to this tick mark? Of course, that's 5 minutes, the full thing. But it's 11:04, so this shaded area represents 4 minutes or 4/5 of that section. Right? Now remember, each section is 30 degrees. So 4/5, I'm going to do some canceling, of 30 degrees. 4 times 6 is 24. So section A is 24 degrees. Okay? Section B, that's dealing with the hour hand. Now here's the important thing to think of here. This hour hand, does this shaded area represent the number of minutes until the next hour or since the last hour? And I hope you say that this is the number of minutes until the next hour, right? Because of the direction that this thing moves in. Now remember, how many minutes is it until the next hour? It's 11:04. So that means this little section is 4 minutes. Remember, it takes 60 minutes for the hand to traverse this whole zone. So if that's 4, this is 56. So we still have 56 60ths because of 60 minutes in one of those sections times 30. You don't even need a calculator for this. Remember, 30 over 60 reduces to 56 over 2, which you get 28. Add those things together, ba-bam. The angle of the hands of the clock at 11:04 is 52 degrees. If you got to watch that again, please do so. I'm going to do 1 or 2 more in class, but I will tell you, I'll give you a couple here if you want to practice. 11:24, you should get an answer of 162 degrees. Okay. All right. And if you did 407, these are just a couple to practice with. You should come up with 81.5 degrees. All right, see me if you got questions. Remember, office hours every green morning. Okay? Be good.